Not long ago, Tekla had this Tekla Global BIM Awards for 2020. These awards showcases more than 120 industry-leading BIM construction projects from around the world. Today, we have the pleasure to see a presentation of the best BIM project and best infrastructure project awarded, which is Randselva Bridge, and which has been designed by Sweco from Norway. Our guest is Øystein Ulvestad, and he is going to tell us some details and show us a little bit this bridge. Welcome, Øystein.
Thank you very much. It's a pleasure to be here. It's always fun to talk about your own projects, and this project is very special for me. So thanks for letting me talk about it.
It's so nice to have you here. This is amazing. I think it's very exciting to see more details about the project. Not only the shell of it, but also some things more detailed about this. So I'm really happy that you accepted my invitation, and I'm sure many people will see this very as a very nice project and learn many things from here.
Thank you very much. It's the bridge itself. It's a huge bridge, but it's for Amandorito, the company that did the calculations. This is business as usual. They've done 70 bridges like this, but the special thing here is that this is being built without drawings, and it's a bridge this size has never been built before without drawings before. So that's a special thing.
Yeah, that's amazing. Yeah.
And as we'll talk about later too, we won the prize for the best BIM project in the world this year. So that was a huge honor. And then when you've been working for a long time hard with something, it's a very valuable definer that you did something right.
Yes, it's very fulfilling. It's definitely very fulfilling and motivating for the future projects.
So I guess without further ado, we'll start presenting a bit about the project and what we've done. What is special about this way of working, and what works good and what does not work so well. Our first slide here, we see pictures from site. This is Randselva, about 1 hour outside Oslo in Norway, and the bridge is 634 meters long. On top we see pictures from about a month ago at site, and below is parts of the BIM model. So what will we talk about? We'll talk about what's BIM, the history of drawingless projects, the method that we are using, pros and cons of this way of working, and the status in Norway and in the world of drawingless projects. So first, just to clarify, BIM and IFC, which are very important words in this way of working. BIM, we say that whenever you model an object, a 3D object, if you ever attach information to that object, then you have a BIM model, because then you can start sorting information and making filters in your model. So if I press this element of the pier, we'll get up quite a lot of information here. We have 12 attributes that are specific attributes, and then we have 10 free attributes that we can use as we want ourselves. So here we have a curtain with E16 projects. We have one curtain for concrete information, and the rest of them are that's things that are more or less exported from Tekla or made in Solibri automatically.
May I ask you something regarding these properties? Is this something that you agreed with the contractor, with the builder, to have all this, or this has been required by the client?
The Norwegian authorities, Vegdirektoratet, have they have a set of parameters or attributes that they want us to include, and some of it has been also agreed upon with the contractor.
Okay, I understand.
There's definitely room to improve this, and that's work that's being done as we speak with Vegdirektoratet in Norway. So we're trying to standardize this even more, and there would be room for a lot other things like price or delivery date or CO2 emissions. So there's definitely things that could be included here. Well, the other thing is IFC. For people who don't know what IFC is, it's like a PDF just in 3D. So IFC contains a structure, a 3D structure with attributes attached to it, but it cannot be changed or overwritten. So it's like a freeze in time for a 3D model. Okay, just to talk a little bit about the huge changes that has been going on in the building industry. There's slow changes and then there's revolutions, and I'd say that in my time as a structural engineer, I've seen three major revolutions. One was when I started 3D modeling. For me, that happened 2003. And then 2017, it was two huge game changers, parametric design and model-based design. Model-based design allows for drawingless projects, and parametric design, we'll talk a bit about that later, but that's a set of rules that can be set up on a computer to assist design. So this is trying to show how we've been working in structural engineering. For a very long time, probably thousands of years, we have been making structures based on 2D drawings. And then the middle section here, we see 3D models being the basis for 2D drawings, becoming a structure. And now in Norway for the last 3-4 years, we've now been eliminating drawings, so we're building directly from a 3D model. For Randselva, that could look like this. Okay, so drawingless projects. The first drawingless projects we did in Sweco was that's now 3-4 years ago. That was a piece of road 24 kilometers long near the Olympic city of Lillehammer, where we had about 40 structures, which looked like these, some of them. And they were all built without drawings. So we had to make a lot of the methodology there. But now we're over to Randselva, which in theory is very much similar, but it's 10 times the length that we ever did before. So it's a lot bigger than anything we've done. And the complexity with over 200 tendons, pre-stressing tendons, and over 200,000 rebars, it's immensely more complicated. That's, as we mentioned before, near Hønefoss. And as we also talked about, it was the winner of this year's BIM Awards. So that was very nice. Okay, going over to methodology then. So what we do is that we use a modeling software. In our case, that's Tekla structure, but it could be Revit or any other software. And then we export these files. Normally we separate into several files, as we'll have a look at soon, and that becomes our BIM model. This BIM model is then the basis for a multidisciplinary control, a third-party control, the construction itself, and then later on operation and maintenance. When we do export, we build our BIM model in Tekla, as we spoke about, and then we export it in several IFC files. So, for example, abutment axis 1 is one IFC file with a form. The backfilling is one file. The information tags is one. Axis is one, and reinforcement is one.
Why this? If I may ask, why are you splitting the model in more IFC files?
The reason, there are several reasons, but the main reason is that when you're building this or controlling this, you don't need all the information at once. You need the information of what you're going to build today or at 12 o'clock today. And so to make sorting of information easier, we found this is a good way of doing it. Also, file size is one issue. The file sizes get very large very quickly, and lastly, there are, if you divide it like this, you have less errors in exporting, because if you, for example, want to export reinforcement, if that's attached to a concrete part, you sometimes have some errors. So we found this way of exporting solves all of those problems.
I see.
And then you collect these files in Solibri or in Navisworks or in Trimble Connect or whatever software you want to use, and that's that will then become what we define as our BIM model. So if we have a look at multidisciplinary control, this is a software called Smart that's Sweco developed, but there are several others that look quite like it. I will see here if we can make this.
What's this? It's a software, installed software, or it's in the browser? It's an application.
Yeah, this is online software, so you don't have to install anything.
Okay, web application then.
Yeah, and it's connected also to a database. So if you want to store information about issues in the model, then that's also stored in a database. So this is the same bridge. So we can then zoom in here and see backfilling. Let's see, model browser. So here are the different files that's contained in the model, and I can turn them on and off, or I could do a section.
Oh, this looks like something that has been built with Forge from Autodesk, if I'm not mistaken.
Yeah, that's probably right.
The interface.
Yeah, this is not my my level of knowledge here is limited, but it is very helpful when it comes to interdisciplinary control, whether that be geotechnics or in this project we don't have all that many other disciplines, but
Yeah.
if you have pipes in the ground or you know, things get complicated very quickly. And here we're also able to yeah, so if I want to track an issue here, I can say what category it is, what area it's in, what discipline needs to solve it, priority, and a date, and then an email is sent and a issue is tracked then. So then we're over to third-party control. And that's being done mostly in Solibri. So here we see a Solibri model of the superstructure, or 1/3 of the superstructure. Here again we can see the different axes, the reinforcement, the form, the information, and the tendon geometry in the different IFC files. And this then is combined into this part of the BIM model. And for communication with third-party control and quality assurance internally, we use these issue tracking in Solibri, which can be exported as BCF files.
Yeah.
Here we have different comments of elements that needs to be changed or has been changed, and then a status of whether they're closed or not.
Yeah.
So then we have our construction part. The model is used for 4 main purposes. One is earthworks and digging and backfilling. The second one is pouring concrete and scaffolding. The third one is third-party products that's cast into the model. And 4 is reinforcement.
Can I ask you a little bit something about regarding the formwork?
Yeah, sure.
Have you generated formwork as well?
We could do, but since that's not part of our scope here, we have not. But what we do is that we either send IFC files or native Tekla files or DVG to the companies that's doing the formwork, so that they are basing their design on our model.
Yeah, sure. Thank you.
So at site, this work would look a bit like this. And to say something about what's hard and what's not so hard, earthworks and scaffolding, coordinates for that is quite easy. Third-party products and casting them in is the hardest part. And then you got your reinforcement that is kind of semi-hard, and we'll get back to this later.
Yeah.
So machine control from 3D models for excavators and machines at site has been done for many years. So that's business as usual. Coordinates from the model is quite straightforward to withdraw that, either points or lines or surfaces.
So when you export from Tekla to IFC, let's say, so you export it in global coordinates?
Yeah.
Okay.
Again, third-party products is a bit harder because you don't always have companies that knows how to do 3D models or read 3D models. So sometimes you need the way around basic drawings here, but we definitely try to avoid that. And then at the end, you got your 3D reinforcement that's being transferred to reinforcement at site.
How do you do that? Do you use any specific tool, or you just how do people that are putting the reinforcement in place, what information they get from the model? How do they get it?
The bar bending schedules, that's exported directly from Tekla. So if it's modeled correctly in Tekla,
Yeah.
then you don't have to make that manually. Then it's exported and produced as shown in the model.
Yeah, but I mean like I don't mean about how you bend the bars, but where to place them exactly.
And as we see here, people are we have these BIM kiosks, but we also have tablets.
Yeah.
And a tablet could, for example, the BIM responsible persons at site will make views. For example, this is a view that would be sort of the start view of your task today.
But what software do you use for this?
There's many softwares, but Solibri or Trimble Connect would be two that you can use. I believe this is taken from Solibri.
Oh, so Solibri can generate this as well. Okay, that's interesting.
And then if you have questions, you can start rotating your view like this. You can start pressing the rebars to get more information. You can enlarge your view so you see further up and further down. So here, first you want to limit your information, and then whether you want, if you need more information, you can start adding more information to your views. So ultimately, you can see the whole model if you would want to, but maybe that wouldn't be very wise if you were doing only the parts of the pier that day.
Definitely.
And then in worst case, these can be laminated and printed on paper and laminated if weather conditions doesn't allow anything else.
Yeah, that's really nice. I was wondering how do you use this? So this is exactly how, like, just think about how easy it is to generate these views instead of just creating drawings.
Definitely, and we'll get back to that as well. But the good thing is, if I do a change in my model, and if I push that to a server, and they the builder, in this case PNC, uploads that, every worker has an updated model in half a minute. So
Wow.
you're not stuck with old revisions. So that's one thing. And then also what this makes us able to do is that we mark every pore face with different position numbers.
Uh-huh.
If you were doing a manual rebar list, that would take endless amount of time if you were to have unique bar bending lists. But this way, you can divide your rebars a lot better, and so that you can pinpoint your rebars a lot more precisely.
Yeah. Regarding this pore facing, do you get this information from the contractor, or it's you who decided?
On this bridge, it's been a discussion between people calculating and us, and the PNC building them, building the bridge, so that we try to we find good solutions that will fit their way of producing and manufacturing at site, and also it has to fulfill some calculation criteria.
That makes perfectly sense.
Now, this 3D model also lets us do some other cool things, like use Trimble Sight Vision. This device makes you sort of see holograms at site. So top left, we see a half see-through column where that's going to be casted. So you can control whether the foundation and the rebar sticking up of the foundation is at the correct place. On the bottom right, we see parts of the first rebars to be installed, and see so you can plan ahead and see potential problems a lot earlier than you did.
Yeah, definitely. Augmented reality, it's amazing.
In some ways, it's cool but not useful, but in other ways, it's becoming very useful as well. We're still in early experimentation phase here, so we'll probably find other good ways of using this in the months and years to come. But for now, it's still already now quite useful in many ways. this is a slide showing a little bit about how easy it is then to order reinforcement for only parts of the structure. So we modeled a pier with a foundation, and then I filter out in Solibri only the foundation, for example, based on pour stage or prefixes, and then I export that. So for people at site, it's a lot easier to order just the reinforcement you need, like more of a just-in-time principle.
Yeah.
Okay, so when we talk about the cons of this way of working, we here see a picture. The top one is, of course, the model, and the bottom one is how it's being built at site. And most of these 200,000 rebars can be moved sideways or up and down a couple of millimeters and sometimes centimeters too without any problems. But some of the rebars need to be exactly where we want them to be. For example, the green stirrups here.
Yeah.
And on the picture from site, we see that stirrup is mounted quite a lot longer further out, away from the tendon head.
Yeah.
And that had to be changed because tolerances were too big. And that's hard in a model, showing what's flexible and what is not.
Yeah, would be possible. I guess it's possible. Wouldn't be just easy to put a note, exactly like where you had the custom fields. You can make a note there and maybe have a way to highlight that. That would be helpful. That like a warning sign or something in Solibri or in the IFC model, like, yeah, this is something very important or something. I think it shouldn't be very difficult.
No, and I agree. The thing is that every bar has at least then 23 pieces of information, 23 attributes attached to it. And getting the people at site to read all those 23 attributes, that can be challenging. So what we found is that we normally want to color code them in a
Exactly.
special color or something like that. But then again, this is definitely can be improved.
Yeah, it must be possible. Like I said, like to find a way to highlight these elements in the model, and even if you have so many attributes, but find a way to get them in your focus. Like here, you must pay extra attention or cautious. You must be extra cautious with that specific thing or something.
Yeah, definitely. Another thing is how whenever you add objects to your model, that can be marked pretty easily. But if you removed anything from your model, like I tried to remove this
Die.
die, then it's a lot harder to communicate that in a model. And we've solved that by adding a revision log that's traceable in the model. I could show you an example of that later. So here we have the same model, and if I want to see my revision log, I press this, and here's a link to the revision log.
Uh-huh. Interesting.
The revision log then is readable here.
Uh-huh.
So this is an easy way of attaching documents to your model. We also have a link to BIM models and to an overview drawing that's required from the government, and also these different information tags are then links to different kind of documents. Going back to our model, or a list of cons. Flexible design is hard to achieve in a model. In a drawing, you can say that these concrete piles, that they should be adjusted so that they go down to bedrock and 1 meter down. But in a model like this, you need to choose a level to model it to. So it's harder to sort of communicate that this is a flexible design.
Mm-hmm.
Another thing is IFC archives. Where are IFC files stored? Are they stored online? How do the digital links work in the future? And can any software read IFC files in 50 years?
CDE, Common Data Environment, for to have control on the versions, right?
Yeah, I'm not too worried about this, but still it needs to be addressed. If we have a look at the pros of drawingless design, one of them is that your design is up and running a lot earlier than when you made drawings. So you can compare them and class check them towards other disciplines faster than you could earlier. The cost of design change then is a lot lower, and your ability to impact cost and performance is increased. Another thing, I don't know if this is a pro or a con, but if you do a drawing of reinforcement in a pier, for example, it can look something like what we see in the bottom right corner, and that's valid for all of these sections. While the reinforcement that is being modeled, that needs to be controlled in all of these sections one at a time to be sure that your design is valid. So you get a very thorough control, but your data needs to be structured so that the control can be done effectively.
Yeah.
Another thing is cross-country work. Now this is the locations of the design team at Randselva, and their beautiful faces. What we want to show with this slide is that drawings are very country specific. So if you want people from another country to help you with the bridge project, you first got to teach them what a drawing looks like in Norway. While a 3D model is much more international, so it's a lot easier for cross-country work to function. And with these cloud-based solutions, for example, Tekla has model sharing that's cloud-based, and I'm sure Revit does as well. This way of working is a lot easier than it used to. Also, you're software independent. The top one is IFC from a Revit file. The bottom one is an IFC export from a Tekla project or a Tekla file.
Yeah.
And in your viewer, if you add the same attributes, they look nearly identical. As we talked about change and revisions, it takes a lot shorter time to do these changes. One thing is that changing reinforcement in a 3D software like Tekla is a lot easier than changing a reinforcement drawing.
Yes.
Also, when you don't need to print new drawings, you can push revisions a lot easier. And what we'll see later too is how this affects parametric design, how this affects our time consumption.
Yeah, and something else important about revisions is that with models it's less error prone. Like with drawings, it's easier to make errors that can be cannot be spotted by checking them always.
Yeah, no, I agree. And as you mentioned, the understanding scope of work becomes a lot better with the 3D model.
Yeah.
This drawing and the 3D view shows the same area, but I'm sure everyone would agree that the complexity of the task is a lot better shown in the 3D picture. And when you even can start rotating this, it's quite progress in understanding scope of work. Again, showing the value and power of parametric design. If we have our road lines, we define an amount of points here, and then we set up rules for the computer to make this this form based on road lines. So here we have our form. We make our mesh, and then we have our surface in Tekla based on parametric design, and then you can parameterize these so that if you want to change different heights, you can do that. And there's more or less no limit to what you can achieve doing this. So,
but what is that? On the right side, it's an integration from Grasshopper, or it's something inside Tekla?
it's a live link from Grasshopper Rhino to Tekla.
Okay, but it's Grasshopper. It's not something built in Tekla structures.
Correct.
Okay.
And we've used this extensively on Randselva, and I'll show you soon.
How much time from the total time of the design it takes you to get to a very basic starting version where you can just play a little bit with different things and go to different aspects of the project?
If you know Tekla and Grasshopper well, it takes you an hour. And
Oh,
the good thing, if you're structured with your scripts, you can reuse them. So if we have a look at Randselva, we made about 95% of the piles with parametric design, about 70% of the concrete, 70% of the reinforcement, 98% of the tendons, and 75% of the details, all based on parametric design. So, at least in theory, this means that if we were to change the road line quite late in the project, if you were making drawings, that would be nearly starting all over again.
yeah.
You would cry yourself to sleep for months. But with parametric design, again, in theory at least, you could get away with only 1/4 of the work, maybe if things were changed. And another good thing is that this can be reused for the next project. So if we have something similar, I'm sure we could reuse at least half of the scripts we used here. So then your time savings is quite large in the end. And then, of course, with the detailed 3D model, you can start using it to make digital visitor centers, like we've made for Randselva, where you, for example, can, again, now this is just pictures, but live walking around in the model, you can start having a look at sound effects, and you can have a look at what the scenery looks like in winter time or at night, with, for example, a VR glasses.
Yeah.
Now, some of the well, I guess the most important thing is how does this affect price and the way we work with limiting errors and mistakes. Now, looking at this is a traditional way of working where drawings are a basis for your design. So the yellow is symbolizing drawings.
Yeah.
And the hours spent for a consultant making drawings. Our second line is the contractor, and you have a light blue period here of the contractor taking drawings and adjusting them to their way of working, and then they'll spend a certain amount of hours using or producing this structure. The bottom line, that's a budget for the project owner. And in Norway, traditionally, that is the road authorities, Statens vegvesen, and now lately, Nye Veier. And they have quite good data saying that they would have 19% increase in cost due to design changes due to errors or unforeseen things and mistakes. Now, when they started demanding BIM models as a basis for drawings, there were a shift in how many hours we spent, because then you have to build a 3D model first, and that becomes a basis for your 2D drawings. So contractors were spending more time. Consultants were spending more time making drawings. The people building were spending the same amount of time adjusting these drawings to their way of working, but normally building it would take a little bit less time because you have less errors in your design. And this was also shown in the Norwegian road authorities' numbers, suggesting that this budget increase was now 8% instead of 19%. So now we're here.
That's some money there. Quite a lot.
Yeah. Now we are still spending more time than we did using 2D drawings. So for us, there's no obvious benefit, but we see that at least the limited numbers we have so far suggests that the contractor use a bit more time adjusting the BIM models to their way of working, but when they start building, they spend less time and have fewer mistakes than they did earlier. And again, we don't have any good numbers yet, but the temporary numbers we have suggest that these 8% has decreased to an even lower number.
Oh, okay.
And of course, if you see the project cost overall, if you limit this by only 1% even, then the extra time we're using making these extremely large and complicated BIM models is already worth it, and maybe 10 times fold.
Yeah, and we did not even talk about operation or maintenance.
Yeah, correct. And a good BIM model would be a huge advantage for them as well.
Exactly. It's much better data quality.
Yeah, definitely. So that brings me to the end of the talk. Anyone that interested in following the Randselva project can go on LinkedIn and find Øystein Ulvestad. I try to post things regularly there. And yeah, maybe we could, I don't know if this is of value. If we have a look at what we're good at and not so good at in Norway and also internationally.
Yeah.
So what we want to do with drawingless design is that we want to have a cost reduction. We want to have faster implementation, lower emissions and better products. And to achieve that, we need a digital worksite, we need digital twins, we need a common digital platform, we need standardization, we need human resource development and benefit realization. And to say a little bit about what we're good and not so good at, I think this is more or less summarizes it.
Mm-hmm.
At least in Norway, we're quite good with digital worksite and digital twins, standardization and common digital platforms, where there's a long way to go. And human resource development and benefit realization is slowly getting there. So there's definitely a lot of things to improve, but we're still at a point where the benefits of this way of working is larger than 2D drawings. So already I'd say there's no way back for us.
Yeah, that's so exciting and so nice to hear. And I really hope that this will become more and more obvious for other places around the world as well.
Yeah.
Awesome. Do you have any other upcoming project you are going to design as well with this method?
We are looking at one bridge. I cannot name it as as we're still working on it, but it has a very similar size and shape, and our goal is to save about 25% of the hours spent making Randselva.
Of course, because you improved yourself as well. If this was you used many new things here, right? And now you can your team become much better, and you got experience. Like, of course.
And I also need to mention Armandorito and PNC that work together with us on this project. Both companies have been extremely flexible in adjusting this new way of working, and they come up with some ingenious new ways of using the models that we haven't thought about ourselves. So it's been a pleasure to work with very, very talented and also very innovative people there.
That's so nice to hear. This is definitely something the cornerstone for the success of on every project. Like, if you have the willingness to collaborate and work together for the sake of and the best outcome of the project, then beautiful things are going to happen, of course. And
Yeah,
you will remember and be glad that you had this kind of team for the project.
definitely.
Yeah. Well, Øystein, thank you very much. It was really nice. And I hope that many people will see and get inspired by this.
Thank you, Petru. It's been a pleasure presenting and talking to you. So I hope to be on the show again soon.
Yeah, of course. When you're done with your next project, you are most welcome.
Thank you very much.
Thank you.